Most organizations think more agents means more automation. They are wrong. Agent sprawl isn't innovation. It's unmanaged entropy. The minute you let every team publish their own little copilot helper, you don't get scale. You get a permissionless decision surface, and then you spend the next year trying to explain why the ROI can't be proven. In this episode, you'll learn the deployable architecture, a master agent as a control plane, and connected agents as governed services. Deterministic authority without pretending the model is explainable. Now let's talk about what you're actually building. The foundational misunderstanding. You think you're building assistants. You're building a decision engine. The marketing story says you're deploying an assistant, a polite interface that helps people get answers and complete tasks. That framing is comforting because assistants sound optional. Assistants sound like user experience. And if the assistant behaves strangely, you shrug and say, AI is weird. In reality, you're not deploying an assistant. You are deploying a distributed decision engine that sits in the middle of identity, data, tools, and action. It interprets intent, selects pathways, invokes capabilities, and emits outcomes. That distinction matters because a decision engine is not judged by helpfulness. It's judged by correctness, reproducibility, and the ability to prove it did what you intended. In enterprise systems, helpful is a non-requirement, correct is the requirement. And copilot-style orchestration, multi-agent or not, will happily optimize for looks correct unless you force it to optimize for is allowed. This is where organizations quietly collapse their own control model. They treat probabilistic reasoning as if it were deterministic workflow. They let natural language become the policy surface. They bury rules in prompts, they call it governance. And then they act surprised when it drifts. Prompt-embedded policy is not policy, it is a suggestion with a half-life. Because prompts are not compiled, they are interpreted. Every run is a fresh execution against a probabilistic system with variable context, variable routing, and variable tool selection pressure. Even if the model is stable, your environment is not. New documents appear, new agents get added, connectors change behavior, permission scopes evolve, and someone tweaks an instruction because a stakeholder wanted a friendlier tone. That is not an edge case. That is entropy doing its job. So the foundational misunderstanding is simple. You think you're building a set of assistants that respond. But the system you're operating behaves like an authorization compiler that emits actions. And the minute you let it emit actions without deterministic gates, you've moved from a deterministic security model to a probabilistic one. Not because the platform is broken, but because you handed the platform the authority to decide. This isn't about smarter AI, it's about who's allowed to decide. Pause. Now let's define what success means in this architecture, because most teams can't articulate it. They talk about adoption, they talk about time saved, they talk about how many agents they shipped this quarter. None of that is a success criterion. Those are vanity metrics. Success criteria for enterprise multi-agent orchestration are boring, and that's why they're ignored. Predictability. Given the same request class, the system follows bounded paths and produces bounded outcomes. Auditability. You can reconstruct what happened, what data was used, what agent was invoked, what tool calls executed, and what approvals gated the action. Controllability. You can prevent categories of actions, not just discourage them. You can disable an agent, revoke a capability, or force human approval without rewriting half the ecosystem. Cost visibility. You can attribute consumption to workflows and capabilities, not just see a token bill and guess who caused it. And there's one more that people avoid saying out loud: decommissionability. If you can't turn it off cleanly, you didn't build a system. You built a dependency trap. Notice what's missing: explainability. Not because explainability doesn't matter, but because it's the wrong control target. You don't control probabilistic reasoning by demanding a perfect narrative of why it thought something. You control it by bounding what it can do next. This reframing changes how you design. If you believe you're building assistants, you optimize for coverage. You want the agent to handle anything. You add more tools, more knowledge, more connected agents, more capability, and you call that maturity. If you accept you're building a decision engine, you optimize for determinism around execution. You separate reasoning from actuation. You treat agent selection as routing, not magic. You treat tools as privileged operations, not convenience features. And you design like every exception will become a precedent, because it will. Once you see it this way, the default trajectory becomes obvious. Without a control plane, every new agent becomes another independent locus of policy, identity, and logic. Over time, the system stops reflecting intent and starts reflecting accumulated compromises. And that's the setup for the next section, because sprawl is not a byproduct. It is the default outcome when intent is not enforced by design. Agent sprawl, power automate sprawl, but with confidence and plausible lies. Agent sprawl is not new. Enterprises already lived through power automate sprawl. Flows built in personal environments, undocumented connectors, brittle dependencies, and temporary exceptions that turned into permanent business processes. Most teams survived it by pretending it was just technical debt. They were wrong then too, but at least the failure modes were legible. Agent sprawl is the same pattern but weaponized, because an agent is not just a workflow. It is a workflow plus language plus reasoning. It contains policy, it contains interpretation, it contains implied ownership, and it fails in ways that look believable to non-experts. The pattern starts the same way, decentralized logic. One team builds an agent to help with onboarding. Another team builds an agent to speed up access requests. A third builds an agent to summarize invoices. None of these agents share a contract. None share an audit model. They share a tenant and a user base. That's not architecture, that's co-tenancy. And then the security model becomes implicit. People assume that because an agent runs inside Microsoft 365, it inherits the safety properties of Microsoft 365. It doesn't. It inherits your permissions model, your connector configuration, and your willingness to let tools execute. That's it. Now here's where most teams mess up. They treat overlap as harmless. If two agents can handle onboarding, leadership calls that redundancy. But in a decision engine, overlap is routing ambiguity. It creates non-deterministic delegation. You are no longer choosing which system executes policy. The model is choosing, and it will choose differently as context changes. Different conversation history, different phrasing, different time of day, different knowledge results, different agent descriptions after someone edits them. This produces 3 predictable failure modes. First, duplicated business rules. 2 agents implement the same policy but with different wording, different assumptions, and different edge cases. Over time, one gets updated and the other doesn't. Now you have policy divergence, and no one can tell you which one is the real one, because both can generate a confident answer that sounds compliant. Second, routing drift. The orchestrator routes to agent A today and agent B next week because the descriptions changed or the user asked the question differently. Nothing broke. The behavior just moved. This is the quietest kind of failure because every individual run appears reasonable, but the system as a whole stops being reproducible. Third, hidden ownership. Agents get created in the same way flows got created, by whoever had the permissions and the motivation. A year later, the original author is gone, the business process depends on it, and nobody wants to delete it because nobody can prove what it will break. So it stays forever. That is architectural erosion with a UI. And now we arrive at the new operational hazard, the confident error. A classic automation failure is obvious. A connector fails, a flow times out, a job returns an error code, you get an incident, you fix it. A confident error is different. The system returns a coherent narrative with clean formatting and a sense of certainty while being wrong. Not maliciously wrong, just operationally wrong. It might skip an approval, misapply a policy exception, or route to the wrong agent, and then it will explain the result in a way that satisfies the average reader. That means your incident response becomes philosophical. You are no longer debugging a failing step. You are arguing with an outcome that looks valid until you replay the trace. And if you don't have a trace, you don't have an incident. You have a rumor. This is why agent sprawl is worse than workflow sprawl. It doesn't just create debt. It creates ambiguity. Missing policies create obvious gaps. Drifting policies create ambiguity. Ambiguity is where auditors and attackers live. The final irony is political. Once agents proliferate, decommissioning becomes socially impossible. Every agent has a user. Every user has a story about how it saved them time. Nobody has a story about how it quietly violated an approval chain because those stories only surface when something breaks publicly. So sprawl grows and governance arrives late, carrying spreadsheets and good intentions. That's not enough because the real cost of sprawl isn't tokens. It's governance debt that compounds until you can no longer prove what your system does. Why ROI collapses. If you can't reproduce behavior, you can't prove value. The ROI story collapses the moment you can't reproduce behavior. Not explain it, reproduce it, because executives don't fund vibes. They fund systems that create repeatable outcomes under known constraints. In a multi-agent environment without determinism, you get what looks like automation, but behaves like improvisation. It completes tasks, but it can't demonstrate reliability across runs. And the second you try to scale it, more users, more use cases, more data sources, the variance becomes the product. This is what unaccountable automation looks like in practice. You can't answer basic questions without hand-waving. Why did this request route to that agent? Why did it invoke that connector? Why did it skip the normal approval? Why did the same request last week take 2 tool calls and today take 9? If the only answer is the model decided, you don't have a system. You have a liability with a chat interface. And once behavior becomes irreproducible, value becomes unprovable. You can't baseline, you can't A/B test, you can't attribute savings, you can't defend spend. All you can do is point at anecdotes and hope the budget committee is feeling generous. Cost opacity arrives next, because the real cost in multi-agent orchestration is not a token bill. The real cost is unbounded execution pathways. You don't pay for an agent. You pay for planning, routing, tool calls, retries, and context growth, distributed across agents that each have their own logic and their own tendency to over-explain. When an agent can choose between multiple tools and multiple agents can answer the same request class, you lose cost predictability. The same intent can fan out into different action graphs, so your finance model becomes a guess. And when finance can't forecast, finance eventually blocks, operational fragility follows, and it's uglier than people expect. In deterministic automation, an incident review asks what failed, where, and why. In probabilistic orchestration, the incident review asks, what did it do? What did it think it was doing? And why did it do something else this time? You end up in run-to-run variance. The same input produces materially different behavior. Sometimes it's harmless, sometimes it's a policy breach. Either way, it destroys your ability to operate the system like enterprise software, because enterprise software is supposed to be boring. Then compliance steps in, as it always does, late and unimpressed. Fragmented audit trails across agents and tools create the worst kind of governance problem. You can't reconstruct the chain of custody for a decision. The user asked a question. The parent agent routed. A connected agent invoked a tool. Another agent drafted a message. Somewhere in that chain, a permission boundary got crossed, or an approval was implied instead of verified. And if you can't produce a trace that shows intent, decision, action, and outcome cleanly, you don't have an audit trail. You have a narrative. Auditors don't certify narratives. Maintenance overhead is the slow death. Copy and paste reuse looks efficient until it forks logic. Then you have silent divergence again. One team fixes a bug in their agent instructions. Another team's agent still contains the old rules. A third team embedded the logic inside a child agent and forgot it existed. Now you're maintaining policy like it's folklore. And this is where the real ROI collapse happens. Scaling decisions stop. Leaders stop funding expansion because every incremental deployment increases uncertainty. You can't promise consistent behavior. You can't forecast costs. You can't defend compliance. You can't decommission safely. So the initiative stalls at useful demo scale. Lots of activity, lots of screenshots, no enterprise outcome. You can feel the reason emerging. The fix is not better prompts. Prompts do not create determinism, they create hope. The fix is a control plane, a system that decides explicitly what is allowed to execute, in what order, under what identity, with what logging, and with what kill switches. And that's the pivot point. The question is not why the AI thought that. The question is what the system allowed it to do next. The deterministic core plus reasoned edge, the only deployable architecture. Here's the uncomfortable truth. You do not get to govern intelligence. You govern execution, and the only architecture that survives enterprise scale is the deterministic core with a reasoned edge. This is not a philosophical preference, it is a mechanical necessity. AI can reason, it can draft, it can summarize, it can propose, it can even plan. But the moment you let probabilistic reasoning directly control actuation, tool calls, approvals, identity changes, financial operations, you have converted your control plane into a suggestion engine, and suggestion engines do not pass audits. So the rule is simple: separate planning from execution. Let the model do what models are good at: interpreting messy input, extracting intent, generating candidate plans, and handling ambiguity inside a bounded step. Then enforce execution through deterministic obligations: explicit gates, ordered steps, mandatory checks, and logged outcomes. Determinism in this context doesn't mean the model always says the same sentence. That is not the goal, and anyone selling that is selling fiction. Determinism means the action graph is bounded. The allowed transitions are known. The approvals are real, the tool calls are constrained, the ordering is enforced, and the outcome is reproducible at the level that matters, what the system did. So if you remember one technical definition, it's this: determinism is bounded pathways plus enforced gates. Everything else is aesthetic. Now most teams get this backwards. They build a brilliant reasoning layer and then bolt on execution as an afterthought. They treat tool access like integration. They assume that because the model is grounded, execution is safe. Grounding is not safety. Grounding is a reduction in hallucination probability. Safety is a reduction in unauthorized actuation. That distinction matters. The deterministic core is the part that owns authority: policy enforcement, identity normalization, tool access, and state progression. It is the control plane. It does not get creative. It does not invent steps. It does not infer approvals. It does not helpfully bypass segregation of duties because the user sounds urgent. It is boring, and boring is deployable. The reasoned edge is where you allow probabilistic behavior, but only inside controlled boxes. A box is a step where the model can produce an output, but that output does not directly execute privileged actions without validation. The model can draft an email, but a deterministic gate decides whether it gets sent. The model can propose an access package, but a deterministic gate decides whether the request meets policy and whether approvals are satisfied. The model can classify an invoice, but deterministic matching rules decide whether payment is allowed. This clicked for a lot of teams when they stopped thinking in terms of agents doing work and started thinking in terms of blast radius management. A probabilistic component must have a bounded blast radius. That means it has limited permissions, it has limited tool scope, It has limited context sharing. It produces structured outputs, and it hits deterministic checkpoints before anything irreversible happens. Once you design like this, the payoff is immediate. You can use AI where it actually provides leverage, judgment inside steps, while keeping the system legible, auditable, and controllable. And yes, this architecture still feels intelligent to end users. In fact, it feels more intelligent because it behaves consistently. The system doesn't randomly escalate, it doesn't contradict itself, it doesn't alternate between overconfidence and paralysis depending on context. It follows a known process and it uses AI to reduce friction inside that process. This isn't about smarter AI, it's about who's allowed to decide. Pause. Now this is the part where people ask, so where does orchestration live? It lives in the deterministic core. Orchestration is not the model thinking. Orchestration is the system enforcing intent at scale, routing to the right capability, controlling context, sequencing calls, enforcing approvals, and emitting a trace you can replay. Reasoning can assist orchestration, it can't replace it, because the system cannot outsource authority to a probabilistic component and then pretend it still controls outcomes. Once you accept that, the next concept becomes obvious. You need a master agent. Not a protagonist, not a super brain, a control plane. The master agent, control plane, not protagonist. A master agent isn't smarter AI. It's a control plane that prevents smart systems from doing stupid things. That sentence matters because most teams build the opposite, a hero agent, a single conversational endpoint stuffed with knowledge, tools, and permissions, expected to handle anything. It looks elegant in a demo. It becomes a disaster in production. The master agent is not there to be impressive. It is there to be accountable. Its job is to hold state, enforce gates, and route work to govern capabilities. It should behave like infrastructure, quiet, deterministic, predictable, auditable, and frankly boring enough that nobody argues about what it meant. So what does that actually mean in practice? First, the master agent owns workflow state, not conversation vibe. State, where are we in the process? What has been validated? What remains outstanding? What approvals exist? What identity context is in effect? If you can't point to a state machine, you don't have orchestration, you have improvisation with logging. Second, it owns gating. Every privileged step, anything that changes a system of record, grants access, commits money, creates an account, sends an external message, must pass through deterministic gates that the master agent enforces. Not because the model can't be trusted, but because trust is not a control mechanism. Gates are. Third, it owns tool control. The master agent decides which tools may be called, when, and under which conditions. It does not allow open-ended tool choice just because a user asked politely. It enforces least privilege by design, not by documentation. If a workflow doesn't require a connector, that connector is not available. If a capability requires elevated permission, the elevation is explicit, temporary, and logged. Fourth, it normalizes identity. In a multi-agent world, identity becomes fragmented fast. Different auth contexts, different connection owners, different scopes, different consent histories. The master agent must make identity a first-class object, which user initiated, which service principal executed, which delegated permissions applied, which approvals bound the action. Otherwise, you end up with the agent did it as your audit narrative. That is not a narrative, that is an admission. Fifth, it locks like a system, not like a chatbot. You need consistent, structured traces. Intent classification, routing decision, agent invoked, tools called, parameters passed, outputs returned, gates evaluated, approvals satisfied, and final outcome. This is not optional observability. This is the only way to make probabilistic reasoning operationally tolerable. Now, here's where most people rebuild the problem. They let the master agent do domain work. They let it draft the policy response. They let it infer the approval. They let it decide the exceptions. They let it helpfully bridge gaps because it seems capable. Don't. The moment your master agent gets clever, you've rebuilt a monolith, except now it's a monolith with probabilistic behavior at the center. You have taken the component that must be deterministic and turned it into another entropy generator. So the master agent stays thin. It does not contain business logic. It contains routing logic, gate logic, and control logic. It delegates domain work to specialized agents with explicit contracts, bounded permissions, and testable behaviors. And it should never do four things. One, it should never invent process steps. If the workflow requires an approval, it must request it. It does not infer it from tone, hierarchy, or urgency. Two, it should never bypass segregation of duties. If the same actor can request and approve through an AI shortcut, you just automated fraud. Three, it should never expand scope based on convenience. If the user asked for, and also that's a new intent. New intent means new routing and new gates. Four, it should never hide uncertainty behind narrative. If a gate fails, it reports the gate failure, not a friendly alternative story. If you build it this way, the master agent becomes your enforcement point, your kill switch, your policy compiler, the thing you can show an auditor without embarrassment. And once you have a control plane, you need something worth calling. Governed services, explicit capability boundaries, connected agents, Connected agents manage services for enterprise capabilities. Connected agents are the part most teams misunderstand because they hear agent and they think chat. That's not what they are in an enterprise architecture. A connected agent is a managed capability surface, a service, an owned interface with a contract, and if you don't treat it like a service, it will behave like every other unmanaged integration you've ever regretted. The point of a connected agent is not that it can speak. The point is that it can be called. Called predictably, called with bounded permissions, called with a description that tells the orchestrator when to use it and when not to. This is the difference between a zoo of clever assistants and an internal platform. The master agent becomes your control plane. Connected agents become your governed services. So let's define the contract, because that's where determinism is won or lost. A connected agent needs an explicit capability boundary. HR benefits questions is a boundary, and book vacation is a boundary. Create a ServiceNow ticket is a boundary. Look up invoice status is a boundary. A general productivity helper is not a boundary. It's a cover story. Once you have that boundary, the agent gets a description that acts like an API definition for the orchestrator. This is where most teams stay vague, because vague feels flexible. Vague is routing ambiguity, and routing ambiguity is non-determinism. So the description must contain three things: in plain language that still reads like a contract, what it does not do, and the prerequisites for safe invocation. If the agent can only operate on approved HR documents, say so. If it must never send an external email, say so. If it can write drafts but not execute changes, say so. This is not documentation for humans. It is a routing signal for a distributed decision engine. And because it's a connected agent, it has its own lifecycle. That's the entire point. Versioning matters. You can publish V2 without silently mutating V1. You can deprecate, you can roll back, you can kill switch the capability if it starts producing the wrong outcomes. You can put an owner on it, an accountable team, a mailbox, an on-call rotation if you're serious. This is where governance becomes real, because now you can govern capabilities instead of conversations. Connected agents also give you a security boundary that embedded agents can't give you cleanly: dedicated authentication configuration. That matters because auth is where most multi-agent fantasies die in production. You can scope permissions per capability. You can separate identities. You can decide whether the agent runs with the user's context, with an application context, or with a constrained service identity. You can isolate blast radius by design, not by policy memo. And when someone asks, who allowed this agent to do that? You can answer with something other than silence. Operationally, connected agents are also where you get reusability without copy-paste entropy. Approve once, reuse many times. The travel policy agent can serve HR onboarding, expense review, and a travel booking workflow without 3 teams re-implementing policy interpretation 3 different ways. The invoice validation agent can be called by procurement, finance, and vendor management without cloning logic into separate helpers. This is what platform looks like. But there's a constraint. You must keep connected agents bounded. The moment you stuff a connected agent with 5 unrelated capabilities for convenience, you've recreated a monolith. The orchestrator loses routing clarity. The agent becomes a second control plane with its own drift, its own exceptions, and its own political constituency. So you publish capabilities, not personalities, and you design for failure. Every connected agent must assume it will be invoked in weird context, with partial information, and with adversarial ambiguity. Not because users are malicious, because language is messy and systems amplify mess. So you enforce structured input and structured output wherever possible. You return machine-usable results, not just prose. You validate before actuation. You surface refusal states clearly. You log every tool call and every gate interaction as part of the trace chain the master agent owns. If you do this right, the orchestrator becomes simple. It routes to services. It doesn't negotiate with improvisation. And that's the payoff, a catalog of governed capabilities that can scale across teams without turning your tenant into conditional chaos. Now, to make this deployable, you need to understand the coupling decision, because not every capability should be connected. Some should stay embedded. And that decision is the difference between architecture and sprawl. Embedded, child agents versus connected agents, coupling is the real decision. Most teams treat this as an implementation choice. It isn't. It's a coupling decision, and coupling decisions are how architectures either scale or rot. An embedded child agent is an internal module. It lives inside the parent, it inherits configuration, it ships with the parent, it shares the same overall lifecycle. That means it's fast to build, fast to modify, and politically easy because one team can own the whole thing. A connected agent is a service. It has its own lifecycle. It can be consumed by multiple parents. It can be owned by a different team. It can have dedicated settings, including authentication configuration. That separation is not overhead. That separation is what prevents every new workflow from becoming a new fork of policy and logic. So the decision is simple. Are you designing a workflow or are you designing a capability? If it's workflow-specific glue, context shaping, intermediate formatting, step local reasoning, embedded. If it is a reusable enterprise capability, HR policy interpretation, identity lifecycle operations, invoice validation, ticket creation, vendor lookup, Connected. The thing most people miss is that reuse is not just convenience. Reuse is governance leverage. If you want to approve and audit a capability once, you need it to exist once. That means connected. Now, here's where most people mess up. They build embedded child agents because it's easy, and then they copy the parent agent because another team wants the same thing. They tell themselves it's temporary. It never is. That's how hidden sprawl is manufactured. The sprawl moves from too many agents to too many near-identical agents. Embedded agents are not inherently bad. They're the right tool for bounded single-team systems. They let you decompose complexity without turning every module into a published service. They keep iteration tight. They reduce cross-team dependency. And when the whole workflow is owned by one team, this can be exactly what you want. But embedded agents have an architectural cost. They are coupled to the parent's context and lifecycle. That coupling becomes a problem the moment you need any of the following: independent versioning, independent rollback, independent kill switch, independent authentication boundary, or independent ownership. And those needs are not exotic. They are guaranteed as soon as the workflow touches regulated domains. So there's a rule for regulated systems, and it's not negotiable. Default to connected agents for any touchpoint that changes identity, money, or employment state. HR, finance, IAM, procurement, and anything that can create or grant access. The reason is not that embedded agents are less capable. The reason is that embedded agents erase the boundary where governance should live. If the child agent shares the parent's identity and tools, then the boundary between reasoning and actuation is softer than you think. And soft boundaries turn into incident reports. Connected agents give you a harder boundary. They force you to define a contract. They force you to publish. They force you to name an owner. They force you to think about lifecycle. And that friction is productive. It's the same kind of friction that stops someone from deploying an unreviewed service directly into production. In other words, it's the point. Now, there's a second-order effect that matters even more. Orchestration quality degrades as the choice set grows and overlaps. If you embed every child agent inside a parent, you're building a private ecosystem inside that parent. The parent gets heavier, the routing problem gets fuzzier, the temptation to just let the parent handle it returns. Over time, you rebuild the monolith because the parent has too many responsibilities and too many internal variations. Connected agents reduce that pressure by moving capability ownership outward. They make reuse explicit. They make duplication harder. They make sprawl visible. So the deterministic decision rule is this: reusable capability, connected. Workflow-specific logic, embedded. And if you're tempted to call something workflow-specific because you don't want to publish it, you're not making an architectural decision. You're avoiding governance. One more practical checkpoint. If two teams are going to depend on it, it must be connected. If it needs a dedicated auth configuration, it must be connected. If it needs a rollback plan, it must be connected. If it might need to be killed quickly without deleting the whole parent, it must be connected. Everything else can be embedded. Make the coupling decision early because changing it later is expensive. Not technically, politically. And once you commit to the right coupling model, the next problem emerges immediately. Orchestration quality depends on routing signals, not vibes. Routing determinism, descriptions, invocation rules, and controlled context sharing. Routing determinism is the part everyone handwaves because it looks like just descriptions. It is not. It is the selection logic for a distributed decision engine. And if you leave selection logic to vibes, you get non-deterministic execution. In Copilot multi-agent orchestration, the orchestrator routes based on what it can infer from agent descriptions, instructions, and the current context. That sounds convenient until you remember what infer means. It means probabilistic classification. It means drift. It means the same request class can land in different places depending on phrasing, conversation history, and which agent description someone improved last week. So you design routing like you design APIs, explicit contracts, explicit invocation rules, and explicit constraints on context. Start with descriptions. The thing most people miss is that an agent description is not marketing copy. It is routing signal. It must include 3 elements, and if anyone is missing, your orchestrator will guess. First, capability scope, what it does, stated narrowly, not helps with HR. That's junk. Answers employee questions about benefits based on the HR benefits knowledge source. That's scope. Second, exclusion scope, what it does not do. Does not create, modify, or approve employee records, does not send external emails, does not perform access changes. That matters because the orchestrator needs negative space. Without it, overlap looks valid. Third, prerequisites, what input it requires to behave deterministically. Requires employee ID, requires invoice number, requires manager UPN. If the agent can't operate without a key, the description must say so, otherwise it will attempt to operate anyway, and you'll get confident nonsense. Now move from descriptions to invocation rules. This is where you stop hoping and start enforcing. Invocation rules are simple sentences that reduce routing ambiguity. Use this agent when, and do not use this agent when. Write them like guardrails, not aspirations. If you're using connected agents, treat these rules as part of the contract, version them, and change them deliberately. Random edits are entropy. A usable pattern is trigger phrases, trigger objects, and trigger intent. Trigger phrases are the user's words. Trigger objects are the identifiers that appear. Trigger intent is the action category. So you say, use the invoice validation agent when the user provides an invoice number, asks about payment status, matching, exceptions, or vendor compliance. Do not use it for general finance policy questions. Route those to the finance policy agent. That's not poetic, that's deterministic. And yes, this will feel rigid to people who want the system to just understand. They are optimizing for demo flow. You are optimizing for enterprise behavior. Now, context sharing, this is the quiet killer. Passing conversation history to a connected agent is not a harmless convenience. It is context injection. It changes behavior. It increases ambiguity. It can contaminate routing and cause the cold agent to answer the wrong question confidently because it saw a prior topic and decided the user must mean that. So you treat context like privilege. You share the minimum required for the capability to execute. If the connected agent is performing a bounded operation, like looking up a record, creating a ticket, validating a policy, do not pass the entire conversation. Pass structured inputs, identifiers, normalized intent, and only the fields required for that step. Give it the smallest possible window to improvise. If the connected agent is a knowledge Q&A capability, context can help, but only if you accept the trade-off. Better conversational continuity, lower reproducibility. When in doubt, isolate, and never pass context across trust boundaries. HR context into finance is not helpful. It is a data leak waiting for a justification memo. Multi-intent queries are where orchestration either looks professional or collapses into conditional chaos. When a user asks check invoice 1042 and also update the vendor address and send a note to procurement, that is not one request. That is 3 intents. If you let the orchestrator decide how to sequence that, you will eventually get out-of-order execution. The email sent before the update attempted without validation, the wrong agent called because it latched onto the first noun. So the master agent must split work intentionally, detect multi-intent, decompose into ordered steps, apply gates per step, and only then invoke agents. Do not let one chat message become one execution graph. Practical guardrails are boring but effective. Explicit routing patterns in the master agent instructions, narrow agent descriptions, exclusion rules, and controlled context. It is not glamorous, it is deployable. Operational prerequisites, publish, connectable toggles, and the boring parts that fail first. This is where good architectures quietly fail. Not in the manifesto, not in the diagrams, in the toggles, the publish buttons, and the identity plumbing that nobody wants to own. Connected agents only function as governed services if you actually treat them like governed services. That starts with the prerequisites that feel beneath you, but will still take you down. First, the agent must have a description, not because humans need it, because the orchestrator routes based on it. If you leave the description empty or vague, you're not moving fast. You are making routing non-deterministic by design. You are instructing the system to guess. Pause. Guessing is not orchestration. Second, generative mode has to be enabled. This is not a philosophical setting. It's a capability flag that determines whether the agent participates in this orchestration model at all. Organizations routinely miss this because they assume it's an agent, therefore it's agentic. No, it's a configuration state. Third, the connected agent toggle must be enabled. Let other agents connect to and use this one. By default, it's often off. And the off by default posture is correct because reusable capability surface should not be accidental. But operationally, it means teams build the agent, demo it in isolation, and then wonder why the parent can't see it. The system isn't broken. Your design intent was never compiled into configuration. Fourth, the agent must be published. This is the part that irritates people because it introduces Lifecycle, and Lifecycle introduces friction. Good. Publish is the line between a draft and an enterprise surface. If you don't publish, you don't have a callable service. You have a personal experiment. Now here's the trap. Teams think these prerequisites are the work. They are not. They are admission to the work. Because once you publish, the operational reality arrives. Credentials and connections. Connected agents that call tools often require connection setup, and those connections often need to be refreshed after publish. This shows up as the most humiliating failure mode in enterprise AI. The agent routes correctly, the logic is fine, the tool is correct, and execution fails because the connection manager wants you to click sign in again. Emphasis. That is not an edge case. That is the default state of loosely managed identities. So the rule is simple. Every connected capability must have a credential maintenance posture. Who owns it, how it's renewed, what happens when it expires, and what the system does when it can't execute. If the answer is it'll probably work, then it won't. Not at scale. Naming is the next silent failure. People treat names as UI, not governance. Names are governance. Names survive longer than owners. Names end up in teams, in links, in documentation, in training, in screenshots, in executive decks. And renaming, as multiple demos have shown, is not always clean. So early naming mistakes become long-lived defects. This matters because your internal agent catalog becomes your control surface. If the names are unclear, the catalog becomes a rumor mill. Then there's tenant reality. approvals, propagation delays, and admin gating. Publishing an agent to teams or to organizational availability often requires admin approval. That means your deployment pipeline includes humans. Humans introduce latency. Latency creates shadow deployments. People work around the process by sharing direct links, testing in private chats, and, just for now, enabling broad access. And every workaround becomes a precedent. This is why governance erodes, not because people hate governance, but because you designed governance as friction without giving them a deterministic path through it. So design around this friction. Stable endpoints matter. If your connected agent is a capability service, treat it like one. Version it. Publish v1, add v2, deprecate v1. Don't edit in place and pretend it's harmless. Edit in place is how you create run-to-run variants across time, and then you act surprised when last month's process behaves differently this month. Rollout strategy matters. If an agent change can affect financial or identity workflows, it needs a rollout posture, limited audience, measured telemetry, and a rollback plan. Not because you're paranoid, because you're operating a decision engine. And yes, you need a kill switch mentality, not a delete button when the incident hits production. A deliberate ability to disable a capability surface quickly with known blast radius. That's what makes the deterministic core credible. The uncomfortable truth is that these boring parts are where multi-agent orchestration becomes enterprise software or becomes another demo graveyard. You don't earn ROI by shipping agents. You earn ROI by keeping them callable, governable, observable, and reversible. Case study, Joiner Mover Lever, JML, Identity Lifecycle as an anti-hallucination test. Joiner Mover Lever is the fastest way to find out whether your multi-agent architecture is real or whether you've just built a persuasive autocomplete layer on top of a fragile process. JML is brutal because it is audited, dependency-heavy, and intolerant of creative interpretation. A joiner event touches HR data, identity creation, access assignment, licensing, mailbox provisioning, device enrollment, application entitlements, and often privileged role eligibility. A mover event touches least privilege and role drift. A lever event touches revocation, retention, legal hold, and the operational reality that accounts linger unless something forces them to stop existing. This is why JML is an anti-hallucination test. It punishes helpful. If your system behaves probabilistically at the execution layer, JML doesn't fail loudly. It fails quietly, and quiet failures in identity are not bugs. They are breaches with better grammar. Here's what non-deterministic failure looks like, and it's always the same shape. Out-of-order provisioning. The system creates the account and assigns roles before a background check gate clears, or it assigns access before the manager approval exists, or it grants a default starter bundle because the request sounded urgent and will fix it later. Later never arrives. Skipped approvals. The model interprets an email thread as implicit approval, or it reads a Teams message as consent, or it sees please proceed from someone who isn't an approver. And because it can produce a coherent explanation, nobody notices until an audit asks for the approval artifact. Role guessing. The system infers job function from a title and assigns access packages that were never requested. This happens because titles are messy, HR data is inconsistent, and the model tries to be useful. It is being useful. That's the problem. Lingering elevation. Movers keep old access. Levers keep dormant accounts. Privilege eligibility remains assigned because the deprovisioning step ran most of the way, and the system reported success in narrative form. Now take the worst failure mode, the silent breach. Slow. The system performs a non-compliant action and then produces a compliant-sounding narrative about what it did. It writes the post-mortem for you in advance while still being wrong. Pause. This is where teams confuse observability with storytelling. If your trace is prose, you don't have a trace, you have plausible deniability. So what does deterministic orchestration look like for JML? It looks like a boring path with enforced gates and AI only inside the steps. HR validation is first, not the user said they're hired, a validated record from the system of record. If the HR system is missing data, the process stops. It does not improvise. Background check gate is second, if applicable. If it's not cleared, the process does not proceed to identity creation. No exceptions. Exceptions become entitlements. Manager approval gate is third. Approval is an object, not a vibe. If the manager hasn't approved, the process stops. The system can draft the approval request. It cannot infer approval. Create identity is fourth. Only now does the system create the user, apply baseline attributes, and establish the authoritative identifier. This step is deterministic. Same inputs, same outputs, same logs. Mapped roles and access packages are fifth. This is where teams get tempted to let the model assign what makes sense. Don't. You use a deterministic mapping, job code to access package, department to baseline groups, location to licensing, and explicit exceptions routed to a queue. AI can help classify ambiguous requests into known categories, but the final assignment must be policy-driven, not narrative-driven. Provision apps is sixth. Each app provisioning call is a privileged action with its own tool scope. The master agent sequences them and logs them. Connected agents perform the bounded operations per system. Failures are explicit and retriable. No silent partial success. Verify least privilege is 7th. You don't end JML at provisioned, you end at verified. The system compares assigned entitlements to the policy baseline and flags drift immediately. That's the control plane doing its job. Log closure is 8th, intent, decision, action, outcome. Every gate, every approval reference, every tool call, a trace you can replay. And this is where AI still helps, safely. It extracts intent from messy HR tickets. It summarizes what's missing. It drafts communications. It proposes which access package a request might align with as a recommendation. It triages exceptions and routes them to the right human queue with context. But it does not execute privilege by inference, because JML is where close enough becomes unauthorized. If your multi-agent system can pass JML repeatably auditable with bounded variants, then you have a deployable architecture. If it can't, you don't need more agents. You need authority enforced by design. Alternate case study, invoice to pay, three-way match, and why helpful approves fraud. Invoice to pay looks boring until you realize it's one of the cleanest demonstrations of why helpful is not a control model. A three-way match exists because procurement, receiving, and accounts payable do not trust each other's inputs. That isn't dysfunction, it's segregation of duties expressed as process. You match the purchase order, the goods receipt, and the invoice. If they align within defined tolerances, you pay. If they don't, you route to exception handling. The system is allowed to be slow here because the system is preventing you from paying the wrong entity for the wrong thing with the wrong authorization. Now introduce a multi-agent orchestration layer with helpful defaults and watch what happens. The first failure mode is tolerance bypass. The user asks, can you just get this paid today? The model sees urgency, sees a relationship, sees a supplier name, and it tries to be useful. It decides the mismatch is probably fine. It drafts a justification. It routes around the exception queue. And because the narrative is coherent, the breach looks like productivity. The second failure mode is exception laundering. In mature finance processes, exceptions are where policy lives. Price variance, quantity variance, duplicate invoice detection, supplier bank change verification, tax handling, and spend category controls. If an agent can resolve exceptions by improvisation, it will. It will normalize, it will smooth, it will fix. And what it's actually doing is converting deterministic gates into probabilistic persuasion. The third failure mode is the most dangerous, persuasive notes overriding policy. The model outputs a convincing explanation that sounds like it followed the process. It might even reference the right documents. But unless you can reproduce the exact evaluation path, match results, thresholds, approvals, and tool calls under audit, you cannot prove that payment was allowed. And finance does not operate on trust me. This is why reproducibility matters here more than almost anywhere else. If an auditor asks, why did you pay this invoice, you must be able to rerun the decision against the same policy and show the same outcome. Not the same words, the same allowed action. So the deterministic fixes are not exotic. They're just unpopular because they remove improvisation. Mandatory matching rules. Payment does not proceed unless the three-way match passes within a defined tolerance, with the tolerance value stored as a policy object, not embedded in a prompt. Exception queues. Mismatches route to a queue with explicit ownership. The system can summarize the discrepancy and propose a likely resolution. The system cannot resolve it by narrative. Approval policies. Where policy demands approval, approval is required. Not inferred, not implied, not the vendor emailed our controller. An approval artifact with identity, timestamp, and scope. Logged outcomes. Every run must emit a trace. Invoice ID, PO ID, receipt ID. Match result, variance categories, thresholds applied, approvals referenced, tools called, and final disposition. If the trace is missing, the workflow did not complete. That is how you prevent silent partial automation. Now, where multi-agent helps when you keep authority deterministic is in specialization. You can have an extraction agent that pulls structured fields from invoices reliably. You can have a vendor validation agent that checks supplier status and bank change history. You can have a policy lookup agent that retrieves the actual tolerance rules and approval matrix. You can have a communications agent that drafts exception notices to procurement or the vendor using consistent templates. You can even have a reconciliation agent that assembles the full context for a human approver, what changed, what mismatched, and what the recommended remediation is. That's leverage. But none of those agents should be allowed to approve payment by being convincing. This is where ROI stops being theoretical. If you enforce deterministic gates, you get measurable outcomes. Faster cycle time on clean matches, fewer escalations due to better triage, reduced manual effort in exception preparation, and a completion rate you can actually report without embarrassment. You can attribute cost per run to specific capabilities. You can quantify exception rates. You can show decreased time to resolution. And when something goes wrong, which it will, you can isolate it. You can disable the vendor validation agent without killing invoice capture. You can roll back a policy lookup change without rewriting the entire workflow. You can prove what happened. That's the architecture paying for itself. Because in finance, helpful is how fraud gets a signature. Determinism is how you prevent it. The black box. You don't govern intelligence. You govern outcomes. Enterprise AI doesn't require transparent reasoning. It requires deterministic authority. The black box complaint is valid. It's also misaimed. Most organizations ask, why did it think that? Because that's how humans interrogate other humans. But an LLM is not a coworker with motives. It is a probabilistic engine that generates plausible completions under constraints, given context you often forgot you provided. So when a multi-agent system produces the wrong outcome, the question is not what was it thinking? That's a comforting question because it implies the answer will be understandable and therefore fixable. The uncomfortable question is simpler, and it actually maps to control. Why was it allowed to do that? That distinction matters because wired thought will never be fully reproducible. The same prompt with the same data can still produce variance. Routing can drift. Retrieval can return different chunks, and the model can take different reasoning paths that still look coherent. If you bet your governance posture on perfect explainability, you're building a compliance program on quicksand. You don't need explainability to deploy software safely. You need enforceable constraints, observable actions, and an audit trail that survives scrutiny. That's what enterprise architecture has always been about, even when the marketing language changes. So the trust model shifts. You stop demanding mind reading and you start demanding system control. Intent must be captured explicitly. Decision points must be recorded. Actions must be gated. Outcomes must be verifiable. That's the whole shape of governance in an agentic system, and it's why the deterministic core exists. Now, a lot of teams try to solve the black box with better prompts and stricter instructions. That's not governance. That's wishful thinking with formatting. Prompts can reduce certain failure modes. They can tighten behavior. They can improve grounding. But prompts are not an enforcement mechanism. They are a suggestion to a probabilistic engine. And the moment the system is allowed to execute privileged actions based on suggestions, you have already lost. So govern outcomes, not intelligence. In practice, that means you define what allowed looks like, which tools can be used, under which identities, with which prerequisites, and with which approvals. You define what a valid state transition looks like. You define what must be true before the next step can occur. And you require structured outputs at boundaries so that gates can evaluate facts, not vibes. This is also where people get uncomfortable about sandboxing reasoning. Good. Discomfort is usually a sign that you're finally seeing the real problem. Sandboxing means the model can propose, but it cannot commit. It can draft, but it cannot send. It can classify, but it cannot authorize. It can summarize, but it cannot mutate a system of record. The deterministic core receives the proposal, validates it against policy, checks approvals, and then decides whether execution is allowed. The reason this works is boring. The system becomes testable again. You can replay a run and evaluate whether the gates would have permitted the same actions. You can measure exception rates. You can isolate variance inside a step without letting variance rewrite your environment. And yes, you still accept that the reasoning itself is probabilistic. That's not a defect. That's the product. The mistake is letting probabilistic reasoning become the authority layer. This clicked for cloud architects years ago, even if they don't call it the same thing. Nobody secured cloud by understanding every hypervisor instruction. That was never the requirement. What made cloud deployable was control planes, policy engines, identity boundaries, and logs. In other words, deterministic authority around a complex substrate. Agentic systems are the same category of problem, and the black box objection often hides a deeper fear. If I can't explain it, I can't be accountable for it. That fear is rational. The fix is not pretending the model is explainable. The fix is building a system where accountability attaches to what the system allowed, not what the model generated. So you implement boundaries, you log every decision, you require approvals as objects, you enforce least privilege, you design kill switches, you measure outcomes. And you accept that the model is probabilistic because you've removed its ability to silently expand blast radius. That's not surrender, that's architecture. And when you do it, you get the only kind of trust that matters in enterprise environments. The trust that the system cannot do the wrong thing, even when the model says something convincingly wrong. Deployment posture: build a governed agent catalog, not a zoo. The deployment posture that unlocks ROI is not ship more agents. It is build a governed agent catalog. A catalog is not a directory of clever toys. It is an internal platform surface. Owned capabilities, explicit contracts, versioned change, measurable outcomes, and the ability to disable something quickly when it drifts. The difference between a catalog and a zoo is simple. In a catalog, every capability has an owner and a lifecycle. In a zoo, everything has a demo and a graveyard. Start by treating connected agents as enterprise services. That means every connected capability must have an accountable owner, a description that acts as routing signal, a defined security posture, and an operational runbook. Not an aspirational wiki. A real posture, how it authenticates what it can do, what it cannot do, and what happens when it fails. If you can't answer those questions, it is not a service. It is an entropy generator with a name. Then promote capabilities deliberately. Early on, teams will build embedded agents because it's fast. That's fine as long as you treat it as incubation, not architecture. When the same embedded logic appears twice, promote it into a connected agent and kill the clones. The goal is to converge on one approved capability surface per enterprise function, not to celebrate reuse while silently forking policy. And the master agent must remain the control plane. It routes gates, logs, and sequences. It does not contain the domain logic. It does not become a second brain. It remains boring because boring is what survives organizational drift. Operationally, this means your catalog needs a few mandatory design requirements. 1. Every agent has a contract. Capability exclusions, prerequisites, not pros. A contract. If an agent can draft but not act, that must be explicit. If an agent can act only within a constrained scope, that scope must be explicit. This is how you stop helpful from becoming unauthorized. 2. Every agent has versioning. The enterprise failure mode is edited in place. That is how you create behavioral variance over time while insisting the system is stable. Publish V1, publish V2, deprecate V1. If you need an emergency fix, publish a patched version and roll forward deliberately. You do not mutate a capability surface and then act surprised when last quarter's controls no longer apply. 3. Every agent has a kill switch, not a delete button. A kill switch, the ability to disable a capability quickly without collapsing the entire workflow graph. If a connected agent starts producing bad outcomes or its credential posture fails, you must be able to remove it from routing and contain blast radius. This is how you keep incidents from becoming existential debates about the initiative. 4. Every workflow emits the same trace shape, intent, decision, action, outcome, across the full graph. If each agent logs differently, you will never reconstruct a chain of custody. So standardize observability at the platform layer, not in each team's personal style. You're not collecting logs, you're collecting evidence. 5. Enforce change control. You don't need bureaucracy, you need determinism. Changes to agent descriptions, tool availability, and gating logic are control plane changes. Treat them like control plane changes. Review them, test them, roll them out in stages. Measure outcomes. Roll back when necessary. Governance is not a committee. Governance is a repeatable deployment discipline. Now, if you want executive buy-in, stop selling agents. Sell measurable outcomes. Define success metrics that map to business reality. Completion rate, exception rate, time to resolution, and cost per run. Those metrics are not theory. They are how you show that deterministic orchestration converts probabilistic reasoning into enterprise automation that can scale. They also give you the power to say no. If a new capability increases exception rate or increases cost per run without improving outcomes, it doesn't ship. That is what a platform does. It enforces priorities when enthusiasm would otherwise erode control. And you have to be honest about what you're building. You are not deploying assistance. You are deploying a distributed decision engine with tool access. So your deployment posture must assume drift. New teams will clone things, descriptions will get edited for clarity, permissions will broaden under pressure, and shortcuts will be justified as temporary. Entropy is not a possibility. It is the default trajectory. The only response is to design enforcement into the architecture. This is where the primary refrain belongs because it resets the whole argument back to control. This isn't about smarter AI. It's about who's allowed to decide. Pause. Build the catalog. Enforce the contracts. Standardize the trace. Bound the blast radius. Keep the master agent boring. And you get something rare in enterprise AI. A system that can grow without becoming unknowable. Conclusion. Determinism is what makes AI deployable. Determinism is what makes AI deployable. Let models reason inside steps, but keep authority in a control plane that gates execution and proves outcomes. If you want the next layer, watch the follow-up on building a master agent routing model with connected agent contracts, because routing is where good designs quietly fail. Subscribe if you want more uncomfortable truths about Entra, Copilot, and why governance always erodes unless you enforce it by design.